You're going to see over the next few days or next few weeks, I guess, on Thursdays, a whole bunch of presentations. And I think what you're going to see is that nobody has all of the answers, but I think we'll have given you a lot of the answers to climate change and energy and greenhouse gas reduction. And so what I'm going to talk about today is really one piece of that, which is the financial piece. And what we're going to show is that high performance buildings and deep retrofits can really save you money. And in fact, this is a really important way to go. So hopefully this will move ahead and we'll go there. I pulled this little cartoon from somebody somewhere along the way, and I think everybody thinks that sustainable outcomes are really hard. I think we can all see that there's a lot of short-term outcomes that people follow and often are very wrong. I don't know that the sustainable outcomes are necessarily more complex, but they're going to take a little extra effort. But what we're trying to do is shift the thinking from low first cost to low life cycle cost. And everybody always looks at what is it going to cost today, but that's not what's really important. It's what it's going to cost over the life of the building. And so what I'm going to show you is how to optimize your whole building investment. I'm going to show you the deep retrofits of existing buildings and new high performance net zero buildings can save you 30 to 50% of the total cost of building ownership. And if you have a portfolio of buildings, there's potential for more savings, but I'm not going to deal with that portfolio piece today. So what is the total cost of building ownership? Well, imagine that you have a cookie jar on the counter, and every time that you get a bill that relates to your house or your building, you put those bills into the cookie jar. And there's probably many, many more costs than these, but these are the big major ones that have an impact. And so you put those bills in the cookie jar, and at the end of the year, you add them up and add them to the previous year. And so what you get is an ever increasing cost curve. And what you ideally like to have is a building that has a flat curve. You spend the money once and you never have to spend it again. But I don't think that exists. But what you can say is that a more sustainable building has a flatter curve. So how do we go about this total cost of building ownership analysis, or what we call SEEFAR-Valuation? SEEFAR-Valuation is a life cycle cost analysis, or a total cost of building ownership analysis over the useful life of the building. Now, we say that's typically 60 years because at 60 years, that building will probably need some major retrofit or repurpose, but the building should last much longer than that. And you don't have to go very far, even in our city, which is not that old, to see buildings that are more than 100 years old. And so what we're doing is we're doing a whole building analysis, not just of any mechanical piece or anything else. We're doing a whole building analysis of all major operating and maintenance costs. That includes utilities, operational and material carbon emissions, age-related maintenance and renewal. So this is any building component that needs replacing over time. Your asphalt shingles on your roof, every 20 years, you're going to have to change it. You can't get away from that. It's physics. It'll also include mortgage interest, insurance, property tax. And I think one that people don't often think about is sooner or later in the short term, we're going to have to transition to some form of renewable heating energy. And often that can be a big cost, particularly for commercial buildings. I also want to talk about the importance of high performance buildings versus just, people often just talk about energy reduction, and sustainability is really more than just energy. There's a passive house standard out there, which is a great energy standard, and I think we should follow it, but we need to look at some things beyond just energy. So sustainability is more than just energy, but what we really need to do is integrate and optimize all building performance attributes, energy being one, greenhouse gas reduction, operational material carbon emission reductions, the durability of the materials that we use for the building, the maintenance and renewal costs, the life cycle performance, how long is this building going to last, and how long are the materials that we're using going to last. And if we're deconstructing a building to build this, we should think about that. And finally, I think one of the most important ones is occupant comfort and productivity. And because the occupants or the people that work in the building impact the building in a big way, but the building also impacts them. So what are the objectives of our SEEFAR valuation? Well, first of all, to optimize the whole building investment, reduce the material and operational carbon emissions, reduce the total cost of building ownership. And what we're going to see is that new high performance buildings have much higher value than code built, and also that deep retrofits can achieve net zero ready with higher value than the existing buildings over their remaining useful life. So who wins? So what are the benefits to the building owners of this? Well, if you have $1 million building and it has a 60-year life, you're going to spend $7 to $10 million in operating and maintenance costs over that time period. We think we can address, or we know from experience, we can address about 3 million of that $7 million. And I think there's more opportunity there if we work at this a little bit. And what we see is that we can save 30 to 50% of that $3 million, which is roughly $1 million over the 60 years. So you spent $1 million to build the building, you're going to save $1 million in life cycle costs over 60 years. Pretty significant savings. What occurs in addition to that is that you have protection from future utility rate increases and rising carbon prices. Your building should have a higher asset value that outperforms new code built buildings or existing buildings. And there's still more potential savings here that we haven't investigated. And I think that will come with more experience as we do this. So how does this evaluation help owners and investors? Well, first of all, to understand what the real costs are of owning the building. I do a lot of these presentations, and I always ask architects and engineers, because that's a lot of them, and building owners. But, you know, has anybody ever asked you what it's going to cost to own and operate these buildings? And I very, very seldom get a positive response. Nobody is thinking about that, but I think it's the most important thing that we should think about. What we also want to do is reduce the total cost of building ownership, but we're also going to need to provide appraisers with the monetized value of the high performance buildings. And Peter Squires is going to be doing a session on this later. What is the value of high performance or green buildings? And lower total cost of building ownership certainly means higher profit and lower rent for a building owner. So who wins in the high performance building game? Well, first of all, the owner. His costs are much lower and he's got a building that's more resilient to climate change. The design team wins because their design fees are higher, but I also believe that it's much more rewarding work. The contractor who constructs it wins because the capital cost is higher, so his profit is higher. The bank wins because they've loaned more money and the O&M costs are lower, so there's less risk and less chance of owner default. And in a few minutes, Dennis Cunningham is going to talk about borrowing for green or high performance buildings. And certainly the occupant of the building or the renter wins because their costs are lower, but they've got a building that's more comfortable with better indoor air quality. And certainly the planet wins. So I'm going to give you an example. This is a building in Ontario. It was built as a code-built building. It's a good-sized building, 21,000 square meters almost. It was designed as a code-built building for about $58 million. The owner said, well, what if we made this a passive house building? That bumped the cost to $58 million, which is about a 1.2% premium. And then if we added solar panels on it, it'd be a 4.8% premium. So what we're doing here is we're comparing the base case code-built building to a passive house design building, and then a passive house building with solar. And if you look at the life cycle cost, the 60-year total cost of building ownership, you say with the passive house, we've saved $45 million. And then if you added the solar panels on, that savings goes to 73 million. Just think about this for a second. You invested $60 million and you got back $73 million in savings. Very, very significant. This is what we call a total cost of building ownership curve. It's over 60 years. The total cost of building ownership is on the y-axis. And what you see in the red line is that would be the total cost of building ownership for a code-built building. And the green is the passive house building, and then the passive house with solar. And remember what I said from the beginning is the flatter the line, the more sustainable the building and the less it costs. But you spent extra money up front to build the passive house building with solar, but notice those lines crossed within 6 years. So in my mind, this is a no-brainer to build only high-performance new buildings. You're ahead of the game almost immediately. This is a Winnipeg infill building. It's pretty small, 1,200 square feet. The code-built building would be about 275,000. The passive house building is 324,000. And the owner invested in an extra $49,000, which is an 18% premium. Now, that's highly unusual. In this case, the builder was building this home for himself. He put a lot of extra care into it and made a pretty substantial building. But let's look at the results. Again, we're going to compare the code-built building to the high-performance building. And if you look at the savings, the $960,000 was the total cost of building ownership over 60 years for the code-built, but only $624 for the high-performance building, which is a 35% savings. Even with that high a premium, and that's not a usual case, you're money ahead. But let's look at where the total cost of building ownership curve again. And again, you see the red line is the code-built building, the green line is the high performance building. And again, these lines are crossing before 6 years. So far we've just talked about new buildings. Let's go and look at the situation with existing buildings, because existing buildings are the big problem. I think the number is something in the order of 15 million single family homes that need to be retrofitted, and that doesn't include commercial buildings. In this case, this is an apartment building in Halifax, and this is a deep retrofits planned. And in this case, what they're doing is they're putting exterior panels, insulated panels on the outside of the building, new windows, new air source heat pump, and solar panels on the roof. And they made the building airtight. So let's look at the numbers. So again, comparing the existing building to the deep retrofit. We've reduced the greenhouse gas emissions essentially to zero, the energy to zero, but let's look at the savings. We've saved $1.5 million or 37% over the life of the building. The next thing I wanted to look at here was, let's look at where all these costs come from. And you see in the left curve for the existing building, the big green bar is the energy consumption. The purple bar is the maintenance and renewal costs. The light blue is property taxes and insurance in the orange color. And you'll notice for the deep retrofit building, the green bar is pretty much totally gone. There is a very small green bar on the bottom, you just can't see it. But we got a dark blue there, which is the major building renewal costs. And the other costs have gone up slightly because we've had to maintain the solar panels and those kind of things. So, and the property taxes, we've shown an increase, but that's not always necessarily the case, depending on the jurisdiction. But pretty substantial savings. Well, let's look at the total cost of building ownership curves. Again, the red line is the existing building and the green line is the retrofit. But notice these lines are not crossing until year 27. We still saved $1.5 million or 37%, but people say, well, I don't want to wait that long to achieve the savings. So let's look at another example. This is a building in Ottawa. It was a pilot project, and in this case, they've done the same kind of process where they're putting exterior panel retrofits. This is a Natural Resources Canada initiative. And you'll see in this case, the green line is above the red line. You say, well, why would we do this? Our costs have gone up. So in this case, we added the solar panels on and then the savings went up to $690,000, but those lines are still not crossing to year 36. And you're saying, boy, that's a long time to wait. Well, let's have another look at this. And so we went back and we looked at this building and said, where can we save money on this construction process? Because it was a very first project, a pilot project, and initial costs were pretty high. And what we found was that we could, by looking at each individual building component, we could probably save in the order of 30% of the construction costs. And that increased the savings to 1.1 million, and it brought the savings down, or where the curves cross, down to year 15. And what we have not included in this analysis at this point is what is the improved value of that building. And we believe that we can get below 10 years if we take that analysis into account. So what did we gain out of this? Well, first of all, adding the solar panels to the deep retrofit saved $1.5 million over the 60-year total cost of building ownership. But the order of optimization is important. And the first thing to do is reduce the building load by adding the panels on the outside and then using more durable products to do that. And we've realized in this, and I've shown the example, that we need to reduce the cost of the retrofits. And we see that that's possible. The next thing is you want to get off fossil fuels. That means electrifying, but it also means that you're probably going to end up using heat pumps because that will reduce the energy costs. Natural gas is about 1/3 of the cost of the electricity, and the heat pumps will bring us back to, because you have a coefficient of performance of 3 to 4, so the heat pumps will bring you back to reducing that cost. And now you've reduced your greenhouse gas emissions essentially to 0. And then the last thing you do is add the solar panels on. And the reason you add those last is you've reduced the building load dramatically. That means you need less solar panels, which have less capital cost, but it also means there's lower operating and maintenance costs. And you need to start this optimization process at the beginning of the project. The earlier you start it, the more opportunities you have to reduce the costs. And you have to really go all the way to high performance the first time. There is no point in doing halfway measures and then coming back and reducing this again. For example, let's say you have a house and the wood siding is getting a little bad and it's rotten, and you need to put on new siding. So you say, well, I'm going to put on new siding, but before I do that, I'll put on some insulation. And you slap on, a couple of inches of styrofoam, put on some new siding. But did that get you to net zero? No. So you're going to have to come back in the future, take off the siding, and then add more insulation to get you to net zero. What you also find in this process of retrofit, you've completely renewed that building and it has much higher value. Also wanted to talk quickly about the design process that is currently going on. Most people are designing to a budget not to exceed. They're typically designing the building enclosure to code. And then what they do is they try and decrease the energy consumption with a good mechanical system, but that's always limited by budget. And if the cost gets too high, they apply value engineering to reduce the cost, and they take out all the good stuff. And I really call it devalue engineering, because most of the time they're taking out things that would actually reduce our energy consumption and our greenhouse gas emissions and our maintenance and operating costs. At the end of the day, the owner gets a building that meets his budget, but he has high operating and maintenance costs that increase forever based on the escalation rate of energy and maintenance costs. What we really need to do is educate the design teams about total cost of building ownership. We need to change the thinking from low life cycle cost to low first cost to low life cycle cost. And we need to give the design team a big goal. And I think that goal should be net zero energy or net zero carbon, which is a little more challenging yet. We need to start using integrated project delivery. A more collaborative approach gets better results. And you need to use the total cost of building ownership analysis to optimize the design. And you got to start that optimization process at the concept stage. So what is this total cost of ownership optimization? Design to a budget not to exceed, that can stay. But we need to design to a net zero goal. We need to design a high performance building enclosure, at least passive house standard, with high levels of insulation, airtightness, high performance windows, etc. And we need to decrease the energy consumption to net zero with a good mechanical system, probably geothermal. And we need to stop using fossil fuels, and then optimize the design based on the total cost of building ownership. And then enjoy the savings. So in conclusion, what we're seeing is that this total cost of building ownership system is proven to work. It reduces the total cost of building ownership of both new and existing buildings, and it can be used to optimize the design. And high performance and deep retrofits of buildings have a 30 to 50% lower total cost of building ownership. And that's all, and I'd be open to questions.
So the first one we have here is, have discounts, interest rates taken into account in financial decisions?
Yes, they have.
Nice and simple question. So if people want to, they can raise their hand, put their question in the chat, or just take yourself off mute and roll the dice there.
Thanks, Sean. And thank you, Jim, for your presentation. It was very informative. Have you considered what the costs might be, the net costs or net benefits of putting green roofs on new buildings or retrofitted ones?
In these examples or case studies that we've done, green roofs haven't been included, but they certainly could be. It's a straightforward analysis. If you can, there would be some additional costs for the plants and the green roof that you're going to put on, but there's also some savings. And as long as you can quantify those savings, we can do the analysis.
All right, thank you. Sean, you said you had a question?
I did. Thank you, Laura. So what are the steps for a building owner to begin the process? Like, can you just talk through how this starts and how you get going on this?
Sure. I mean, the design process is not much different than a traditional design process. However, what you want to do is start out by showing, or I guess introducing the concept of total cost of building ownership or life cycle cost to the design team, because they're the ones that will inevitably come up with, should I put on a green roof or should I use a heat pump or all those things? Because most of these designers know about these things. What we're really doing then is bringing them all together in order to say what things have can achieve savings, and then we evaluate those savings and say, oh, should we do A or B or C or a combination of all of them? And so really the design team, once they understand the total cost of building ownership concept, then they can very quickly, if they get it, this process is easy. Does that answer your question?
Well, sort of, Jim. I guess I was wondering more in terms of retrofitting. So if,
Retrofitting, it's the same deal really, in the retrofit process. What we're going to do is we're going to look at the existing building and its existing costs, because what everybody thinks should happen in an existing building is the energy savings should pay for all the maintenance that you haven't done over its life. And it never can. But once you establish the base case, which is here's what the energy costs are, but here's all the maintenance things that need to be done on that building. Maybe you haven't changed the windows, or you need to change the windows, you need a new roof, you need a new mechanical system. So all of these things are existing building costs. And then the design team starts to look at this and say, okay, if we're going to replace the roof, let's add more insulation. If we're going to replace the mechanical system, what are we going to replace it with? And you evaluate those options. Does that answer your question?
yes, thank you.
All right, so we have a few questions in the chat. The first one is from Chris. How do you handle volatility of inputs like energy of finance costs? What level of confidence can you say in the providing on estimates?
So the cost estimates for construction materials are in today's dollars, and the same thing with energy. Everything that we estimate is in today's dollars, but then we're going to escalate that over time. But we're going to use very long-term escalation rates. We know, for example, that inflation has been about 2.7% over the last 100 years. We're not going to use today's inflation rate of 5% because it just went up like crazy. This is a long-term analysis. And we do that for energy. We look at energy rates from Stats Canada over like 40 years, typically somewhere around 4% for most jurisdictions. So you want to look at the long-term rates. Spikes will always get you into problems. So does that answer the question?
I think so. We'll hear from Chris in the chat, I'm sure, again, if it did not. Is inflation put into consideration over the 60 years for determining total cost of building ownership, or is the value of the dollar assumed to be fixed over the extended period? So similar question.
Yeah, we're using long-term inflation rates, typically conservatively 2%, but it's escalated over the entire 60-year period.
Great. And Chris says, yes, that did answer his question. So next question is embodied carbon a consideration in the analysis, like total GHG savings, including embodied carbon for the term of 60 years?
It should be included. It's currently not. Part of the problem is that we don't have a cost for embodied carbon. We have a cost for operational carbon. It's in the fuel that we burn, currently $50 a ton. But currently there's no cost for embodied carbon. We can apply, if you want to use your own cost and apply that, we can put that in. It's pretty straightforward. But somebody's got to do the carbon analysis.